Thanks for that introduction. Uh, good day to everyone, and very happy to be part of this esteemed conference. A lot of learnings, a lot of knowledge sharing. So the next 25 or so minutes, we will take a look at how most of the things that we have been discussing today or hearing about, right? How some of these come together, a convergence of AI, machine learning, 5G on the edge. How does that all look like? So this is going to be more of an experience sharing session, primarily based on our experience dealing with customers who are at various stages on their journey to cloud, AI adoption, machine learning, operationalizing enterprise-grade machine learning models, and so on. So I'm Manoj, and I'm part of a wonderful team that works in the JAPAC region, helping our customers migrate onto the Oracle Cloud, and specifically focusing on AI and machine learning workloads. So this is what we will briefly touch upon. We'll take a look from our experience. What does the lay of the land look like? We'll touch upon machine learning on the edge. We will look at how different is a machine learning model that we usually do, say as part of an academic interest, versus when we talk about enterprise grade machine learning models. And then we will wind up touching upon the complete spectrum, the offerings, the data science platforms, taking some examples to see some of those, how those facilitate enterprise grade machine learning model adoption, deployment, and so forth. So we have been hearing, and we kind of agree, this is changing the world, but not equally. Some are very successful in adopting machine learning or AI, while others, no, it's a mixed story. And few have failed, few have learned, few have retried. But then coming back to the successful ones, success, we know it delivers excellent competitive advantage. So that's a key thing that we keep observing when we work closely with our customers. At the end, it's about business. It's about the ROI. It's about getting the competitive advantage as well, along with every other aspects. So let us take a look at the common challenges. Again, this is a list put together purely based on what we keep hearing. This may not be an exhaustive list, but then these are some of the most common challenges that we keep hearing from our customers. Challenges in adoption, in app modernization, in the cloud journey, in the AI and ML adoption. Specifically on AI and ML, computing power used to be a very common challenge that we hear. Now, there are different dimensions to this challenge. Computing power, it's not really the scarcity of that. Most of the major cloud providers have addressed that. It could be, yes, I developed the best model, but then that could be compute and storage hungry. And I'm in for a surprise when I see the metrics or the cloud meter, right? It could be the fitment, GPU versus CPU. And I coming from a data science background, may not necessarily be the best person to choose that. Or I may not have gone through the right channel in deciding where should my model run. That's a very common challenge that we see. Specifically with customers who are there on the field, they are deploying, they are operationalizing, they are trying to get this run. I'm not really talking about the academics or the laboratory experiments or the research kind of work. Of course, there are different challenges, but then this is specifically, the enterprise models, the machine learning models. Accuracy, we heard Dave talk about that. Again, different requirements do call for different levels of accuracy. We heard the example of COVID prediction, right? So that's another challenge. Privacy and security, we did hear about it in today's panel discussion. That has always been a concern and continues to be. Where does the data go? Where is it residing? Security at transit, in rest, so on. Another challenge, common challenge that we hear about is the awareness itself, the possibilities. What's really possible? Industrial automation, what are the different possibilities? Because technology is evolving at a rapid pace, and every other week you have a more efficient algorithm, be it on deep learning or neural networks. We heard earlier today the problem of bias inclusivity, a major one. Data availability, another challenge. So these are some of the common challenges, and of course, an indicative list, what we hear from our customers. Having said that, acknowledge that, what does the current lay of land look like in machine learning today? If I take the simplest example, all I need is a good data set, which is very much available, multiple sources, and the right algorithm or an optimal algorithm to stand up my first model. Hardware used to be a problem, and today all the cloud providers, they give excellent platforms. And where, yes, it's on the cloud today, so this really is not a major problem. I really need not worry about having GPUs, private GPUs. Once this was addressed, then came the problem relating to latency, real-time decision-making, proximity, how close is your workload to the data center. And cloud providers did address that to an extent as well. Say as an example, Oracle has around 30 plus data centers spread globally. Customers have a good number of options to choose from. Where do you want the data to reside? So we kind of addressed that as well, proximity to the data center. But then think of this use case, a real-time decision-making model that resides on the wing of a fighter aircraft. Which data center will you host that model on? Proximity, talk about that. So that's what we'll spend the next few minutes on, machine learning on the edge. Thanks to the growth in hardware, telecom, 5G, hardware, basically compute, storage, they are much cheaper today. Devices are much smaller. It's very much feasible to pack this and create what we call as micro data centers, have compute and storage packed at the edge of the network today. It's very much easy to have inference run at the edge. Now think about use cases like the autonomous car, right? A lot of decision has to be made real time then and there. Time matters. Data latency, round trips may not be feasible in reality. So the roving edge device is one such example, just to illustrate the point, right? So it's extensive amount of blocks / object storage and compute packed in a rugged device. Use cases of, say, for some mining, deep sea exploration, where you really need some real-time decision making, some kind of a computing and storage available on the edge. So different providers do have different solutions for that, and the roving edge device is one such solution from Oracle, extensively used in such remote edge compute use cases. How does it really work? Let's take a look. So the device is provisioned, it's shipped to wherever the customer needs. Every service available on the Oracle Cloud infrastructure is available, can be made available, can be plugged onto this roving edge device. It is configured It is synced and updated, and then it's transported to the location whichever remote, or it could be on an aircraft. It could be for deep sea exploration. It does the compute. It does the real-time decision making. It has the infrastructure. It has the platform. It has the apps embedded. It's then brought back, if required, synced or copied, and the cycle repeats. So we are really talking about micro data centers. Custom images, custom models can be provisioned on this. So that really shows the extent we have taken this entire capability right to the edge. The possibilities are immense. And talking about machine learning in this entire context, this particular device, the roving edge device, it comes with the MSET2 algorithm. Now, what does this do? Typically, in the IoT space, we do have sensors. We define thresholds. If the temperature goes above X degrees, an event is triggered, or you get a feedback. But then, many a time, it's either there is an inaction till the event is triggered, or then you bring down the threshold to ensure you get an early indicator. The MSET2, as the name states, multivariate state, what we do there is overlay the feeds runtime of multiple sensors so that you really need not wait for a traditional threshold to get the feedback, to get a pulse that something is going wrong. An example was a recent implementation as part of an ATM security device. Multiple sensors in an ATM kiosk. Now, if suddenly the sensors detect multiple people on the sides of the ATM machine or on the back, where on a regular basis, you don't expect someone to go to the sides or the back. If the sensors detect undue pressure on the ATM panels, if the sensors detect heavy breathing from multiple people in the vicinity, all of these are correlated. So you really are, today, traditional monitoring, yes, if someone moves, if there is a significant movement in the ATM machine, alarms are triggered. But then here we are talking about a slight increase in the pressure. But then slight increase in the pressure alone may not be a right indicator, false alarms. So that's why we are relying on multiple sensors. If it's a slight increase in the pressure, coupled with unusual amount of time the card is there in the slotting machine, or someone, sudden increase in the temperature, some gas cutter or something within the kiosk. So you're correlating all of that much, much earlier in the cycle. So those are the possibilities, and this is the depiction of what I just explained. How does that really work? The MSET2 algorithm is backed by 150 plus patents. MSET1 algorithm, this was in play for at least 3 decades. It's used extensively in almost all the spacecrafts. So those are the possibilities at the edge. Taking a step back, coming to the reality, we touched upon this. Not every program or initiative is successful. For every successful machine learning implementation, we see few failures and lots of learnings. And the key reason is the machine learning code, the algorithm, the data structures. Yes, that's a crucial element, but then that's a small part of the overall ecosystem when we talk about operationalizing this entire model. When we talk about enterprise-grade machine learning models. So at least I can say from an Oracle's perspective, we have been in the data business for like 4 decades now. Data has been at the center of whatever we do. There's a lot of insight that we get from this enormous amount of data. That's great. But then when we talk about rolling out enterprise grade models, there is much more to it. We spoke about edge computing devices. We spoke about IoT devices or sensors. Now consider the scenario of sensor feeds. In reality, we don't get a 99.99 feed from the sensors always. There could be instances where the feed fails. It could be the network. It could be the sensor failure itself. Now, a feed failure could denote that the sensor has failed or the device failure or something else regarding the monitoring, right? If it's a photo sensor, this darkness, you may get a 0 or you may not get anything. Or you may get a weak signal. Weak signal could be because of the light is no longer there, or it could be because of a problem with the device sensor. How do we detect that? Infrastructure is another key aspect. Continuous monitoring of this entire ecosystem, machine learning model. So there was an interesting use case again with one of our customers. The use case was, the problem that the customer had was to predict the cash flow or cash replenishment at ATMs in rural areas, right? So you build models, you get patterns, there are seasonal patterns, a weekend holiday has a pattern, there are multiple trends and so on. You build models, yes, it kind of gives accurate results. It gives a good result as to, yes, it's time for, the cash will run out. A new retail outlet opens just close to the ATM and the whole model goes for a toss. The spending patterns change. The footfalls change. Right? So a continuous monitoring, self-learning of models, process management, feature extraction. There could be multiple variables. It's a continuous process. Configurations, automated fashion of doing this. So there are multiple aspects that need to be considered when we go from an academic machine learning model to deploying it. Because business, as we discussed earlier, looks for results and they don't understand the intricacies in few cases, and it's not fair if you're not able to generate, your model is not able to generate at least the promised results. The enterprise data science platforms, again, many cloud providers do have different versions of it, excellent capabilities. We have platforms that combine all of these together, starting from data discovery, ability, connectors that can connect to heterogeneous data sources. This could be sensor feeds. This could be an object store from a different cloud provider. This could be from your on-prem data center. This could be from the social media feeds. This could be geospatial data. So there are connectors, there are frameworks that provide you this amazing data discovery and ingestion capabilities. The same platform gives us provision to engineer pre-processed data. And at least in the Oracle data science platform, we do have machine learning algorithms to take care of pre-processing to an extent. We heard earlier in the day about AutoML. DBAs, database administrators, at least at Oracle, that used to be a mini industry in itself. We used to have thousands of people doing the DBA job. That's no longer required with the new Oracle Autonomous Database, where we have automated the lifecycle management, patching, upgrading, provisioning, P2T of a database. So those are the possibilities, right? Now, these are all baked in an end-to-end platform, and that's what the Oracle Enterprise Data Science platform provides. And there do exist many such platforms from multiple providers. So it's also a matter of awareness, because these are some of the areas where a data scientist struggles. We see that. They struggle on the infrastructure part, they struggle on the data preparation, the feature engineering part, diluting the focus or taking away that crucial bandwidth that's needed for the real model engineer. And similar platforms give very dedicated services, say automated ML, data science, OCI services, AI on VMs, and built on compute, network, storage, security, cloud native, basically all of those factors being considered. So these services are built. The beauty of some of these services are they are born in the cloud. They are cloud native, but then they do have access to the 4 decades of data that's lying around, or 4 plus. And I can speak about Oracle at least. So how do we do it internally? Machine learning. We do have an extensive research lab, as I said, not enterprise grade, but then the focus is about the cutting edge algorithm, which uses the most efficient data structures, which uses the compute and storage in the most efficient manner, and the network, which tells us where to do the inference versus the modeling. Dedicated team. We had a very large customer base of database middleware products. Majority of them were on-prem, and we brought them onto our cloud. We went through that journey ourselves, which today places us in a much better way to advise our customers, because there was this humongous amount of data lying in the data centers of the customers or on-prem devices or whatnot. We worked first. We kind of brought them onto our cloud once we built the cloud. And we couldn't hire those many DBAs to sit after those many database instances. We had to leverage AI and ML to automate most of those database management activities. We have extensive service arms, which, coming up with this rich experience, we do advise the customers, and then a good number of SaaS products where this whole thing is baked together. So it should not, the story, the takeaway there is this whole machine learning modeling and rolling out operationalization, it cannot be seen in silos. It's a change management. It's a journey. There are multiple aspects. All of those should come together. And here is a view of the complete spectrum, at least from Oracle, what I can speak on. So machine learning today is there, a part in some form or the other of every single product and service that we do. On the left, you see ready-to-go applications. So these are some of the SCM or HCM application, and where AutoML algorithms, to an extent, supervised machine learning algorithms, they advise on who could be a potential next best hire. Algorithms on SaaS applications advise the remaining useful life for any parts, inventory. The second category is ready to work. These are platforms where there are experts in that database domain, but then now it's an autonomous DB. So like we discussed earlier today, may not be really replacing the DBA, but then you need not do those monotonous jobs any longer. Your bandwidth can go to fine-tuning your scripts, much more high-end work. And that's really an assistant for you, an intelligent assistant. And the third category is ready to build platforms. So that's the ML tools, the AI, data science service, the language service, vision, all of those. So this third category is meant for the expert user, expert data science user. The first one, the user may not even know. He might be an accountant, he might be an HR, they may not even know, but AI works at the back for them. The middle category, it might be for the citizen data scientist. Yes, you have a fair knowledge, but you really need not write the code, and so on. So that's a complete spectrum. And in our experience, every workload is different. Take 3 banks, certainly they are not the same. 3 banks in the same region, the workloads, the IT infrastructure, the application ecosystem, the interoperability, the downstream systems that entire stack, there are nuances, there are customizations which influence the way you really need to go ahead, or which should be considered when you get into the machine learning / AI journey. With that, let me pause here to take any questions. Okay, I take that as none. Thank you.
No, Doctor. Sorry. Manoj, we have one question. Since
sure.
Versatile cloud systems need high volume of electric energy, how these systems are responsible to handle resilience of the planet Earth? Don't we have a social responsibility to take care of Mother Nature?
Oh, absolutely. So, no two thoughts about that. Again, as I said in the beginning of my discussion, multiple challenges that was purely based on what we see today with the customers. But then, even a step before that, when it comes to social responsibility, many of the starting from the infrastructure, the core truth, right? The data centers. Many of the data centers, they are going the green way today. The way we have many of these modern data centers, thankfully they are in this part of the world, at least we can see, because these are relatively newer data centers, and they are drastically different from the way that we have built data centers 2 decades ago. The compute, the carbon emission, the energy efficiency on the compute at an algorithm level. That's what, when I spoke about 4 teams and the first research team, that's a crucial area of research. CPU cycles for the same instruction execution. So a very good point, and it's a key consideration. Starting at the data center, the infrastructure, the algorithm, the data set level. The choice of data structures, all of that, it's a very key consideration and it has to be adhered to. No two thoughts about it.